Okay, this is Dr. Bankole Ojo Olufunsho Samuel, and I'll be taking a short class on petroleum chemistry. This class is centered around solving some practice questions. I will focus on the ones that I feel will be much more challenging for you. Okay, now we have practice questions. You can see it on your screen. So the first day is describe four primary applications of biomarkers. That's easy. Differentiate between diagenesis, catagenesis, and metagenesis. I gave you as an assignment also. Write short notes on three critical diagnostic ratios for chemical markers. Then the fourth, you are tasked with determining if two oil accumulations 50 km apart are from the same source rock. List four specific biomarker ratios or plots you would use from the notes and explain the logic for choosing each one. So here you are looking at, okay, two oil accumulations 50 kilometers apart. Let me assume maybe we have one accumulation at Badagry and another one at Abara. Okay, something like that. Okay, so we have two oil accumulations 50 kilometers apart, and you're wondering, are they from the same rock? Okay, so how can you know whether they are from the same rock or not? That is what the question is literally about. So what is the first analysis you need to do? One, you do the stirring tenor plot where you check for C27 sterins, C28 sterins, and C29 sterins. Okay, so the proportions of the sterins will determine whether the crude oil is from a marine. You know, when you say marine, that's of course water, right? Whether it's from marine source or it's from terrestrial source. Okay, so for instance, if you have lots of 29 sterins, then you know that the crude oil is from a terrestrial source, that's land. But if you have lots of C27 sterins or C28 sterins, then you can conclude that that particular crude oil is from marine, right? Now, this is the trick. When you remember, we have two accumulations of oil, so you test both oils for sterins. Okay, you expect that if they are from the same rock, then they should have the same type of sterins. For instance, if you test the one at Agbara and test the one at Badagry, then and they both show C29 sterins as the predominant sterin, okay, you can conclude that okay, it is likely that they are from the same source rock. But if you test the one at Agbara, for instance, and test the one at Badagry, and you notice they have different types of sterins, the types of sterins are different, then they are definitely not from the same source rock. Okay, let's assume they have the same type of sterins. Okay, then what other test can you carry out? Then the second one is pristine phytane ratio. This one will show whether the crude oil was produced in an anoxic or in an oxic condition. Okay, remember I told you anoxic means depleted oxygen. That means that environment is not oxygen rich. Okay, and oxic is where you have loss of oxygen. So you expect that if they are from the same source rock, then they should have about the same condition. Okay, so the value might not be exactly the same, that's the pristine phytane ratio, but they should fall in the same category. For instance, you know, if it is less than 1, okay, or whether it is greater than 3. So if one is less than 1 and the other one is greater than 3, then you know that there is a problem. Okay, there's a problem with your crude oil, because when you hack back to what we've been talking about, okay, the phytane ratio shows that low phytane less than 1 signifies anoxic condition, while high phytane greater than 3 signifies oxic condition. So when you test the one at Badagry and the one at Akbara, okay, they should either be both less than 1, both greater than 3. You understand? To show that they are about the same, in the same condition. Okay. But if you have one that is less than 1 and the other greater than 3, then they are definitely not from the same source rock. But now let's assume they are both less than 1 and you still want to do more tests. Okay, remember this is the second test we are now talking about. Now let's move to the third one. Okay, so the third test you will now want to check, okay, is the C29 alpha 20s stirring ratio. Okay, this gives us the thermal maturity. Okay, for this ratio we expect that the whatever value you are getting, okay, should be about the same range. Okay, so now look here, we now talk about the range for C29. You can see it there. So because that's doing maturity and it starts from 0, right? So from 0, okay, you move up and then you have less than 0.25 means that it is immature as the crude oil. 0.25 to 0.4 means that it is in the early peak window, that is this maturing. Okay, then 0.5 to 0.55 means that it is at the peak, that's really matured, okay, and is getting really as in matured, okay, in terms of so we call it the late oil window. Okay, so you have the late oil window, so it has reached its peak maturity, okay, at 0.5 to 0.55. So you expect that in your answer, okay, you should also talk about the maturity should be about the same. Okay, so their maturity should be about the same. Remember, this is the third one now, C29 stirring ratio. Now the fourth test you should carry out is TS open ratio. TS open ratio has to do with the secondary maturity. Okay, remember I showed you the difference between TS and TM the last time I was in class. Okay, so you expect them to have about the same thing. If you have lots of TS, okay, in the one at discovered at or recovered from Badagry, it should be the same with the one at Agbara if they are from the same source rock. So what we are saying is there should be a correlation. Okay, when you analyze both of them, they should overlap. Okay, they should be very similar. Their results should be very similar to show that they are from the same source rock. So that is it. So you just outline these four tests, okay, and talk about the implication. Yeah, and that should be okay. Now, the second question, the downstream sector produces products like plastics, fertilizers, and pharmaceuticals. Trace the conceptual pathway from the original depositional environment recorded by biomarkers like PRPH to the formation of the crude oil feedstock used to make this modern product. So we are just looking at, okay, moving from the ancient environment to the modern feedstock. What do I mean by this? Remember, I told you that crude oil comes from organic matter, whether plants or some small organisms like algae, bacteria, and the likes. Okay, when they die, they lead to. So that's they undergo a process, a long process, okay, that gives rise to what we now get as crude oil. Now, what are the stages? So if you're going to answer this, just answer with stage one, the positional environment. Okay, and you just need to talk about the organic matter accumulates in a sedimentary basin, and the environment dictates the quality, type, and preservation state of the organic matter. That's okay. You don't need to. Then now stage two, you talk about diagenesis and catagenesis. Okay, where diagenesis, talk about the altering of the organic matter. Okay, where it breaks down to form an insoluble complex called kerogen. Next, catagenesis, then there it starts forming the oil, okay, and that's between 60 to 150 degrees Celsius. So that's it. So just the process that is necessary. Stage three, talk about exploration and production. So here the geochemists use biomarkers to find and characterize the oil. That's it. Okay, that's stage three. Stage four, that's the refinery. Okay, at the refinery, crude oil is not used as a whole. It is separated by distillation into fractions and chemically transformed. That's stage four, and then that's it. So when it is refined, that's when we get our final product. So that's the conceptual framework. Okay, so what all I need is just the process. So stay on the process. Okay, so that's it for that question. The third question I'll be looking at is number 6. Three source rocks have the following pH ratios. So rock 1 0.5, rock 2 4.2, rock 3 1.8. Okay, so now want to interpret this result. So after analysis, so we know that when pH is less than 1, right, then the condition is what? Anoxic. That is little oxygen. So it is a reducing situation. Okay, so you have an anoxic environment. So that is for rock 1 because the pH ratio is less than 1. For rock 2, the pH ratio is greater than 3. And when it is greater than 3, then the condition there is oxic. Okay, it's oxic. So you have lots of oxygen. However, for rock 3, you have an intermediate value. It is not greater than 3 and it is not less than 1. So it is an intermediate value. Okay, so here you can call it disoxic. So you can see it there, disoxic. So that is how to answer that question. Okay, so now they said if there is a need for additional assessment, okay, the additional assessment you will need to make is your pain index. Okay, your pain index can confirm the condition. So just mention the C35 homo pain index is the most direct and required next analysis. That's it. Okay, so here draw a blank steering ternary diagram with corners labeled C27, C28 and C29. On this diagram, sketch and label approximate regions or points for A typical marine algal source, B a source with significant terrestrial higher plant input, C a source dominated by diatoms, D a mixed source oil from a coastal deltaic environment. Okay, so looking at it, we know that from the steering analysis, Okay, you can know whether it is terrestrial, it is from marine source. Okay, depending on the type of terrains you find in your sample. So what is A? A is a typical marine algal source. So first thing you need to do is to draw your triangle, okay, with C27. And see C27 there, C28 and C29. Okay, can you see it? Now you move on to labeling it. So A is a typical marine source. So typical marine source is for C27. You can see it. B, you have a source with significant terrestrial. This terrestrial means it's land, right? So that means it's C29. That means the rock, okay, is on land. It's not in the water. Then a source dominated by diatoms. So these diatoms, although they are also marine, but diatoms, okay, will give you C29 sternes. But now you have a mixed source oil from coastal deltaic environment. So this will be in the middle of A and C. You can see it is in the middle of A and C. So that is why it's closer to this place than to B. So it's closer to A and C than to B. No, B is on land. The oil is on land. But A and B, okay, they are both marine. Okay, so a mixed source oil means that from deltaic means is from water actually, or a I'm sure you are familiar with the Niger Delta. Okay, you know there's lots of water there. It's a coastal region, so you have a lot of marine related organisms there and plants. So this is more like um, marine, okay, but not fully marine. Okay, so you have a mixed source oil. So that is an example, and that's how to label it: A, B, C, D, and D. Okay, I've dealt with A8 in class 9. Okay, so I've touched on that. Now with conceptual diagram linking the upstream, midstream, and downstream sectors of the petroleum industry. Okay, so you can see an example there. Okay, upstream, that is where you have the crude oil taken from the ground, right? Midstream, there you have all the pipelines, movement, okay, of the oil from wherever it is drilled to the refinery. Okay, so that's the major thing about the midstream. Okay, so you have laying of pipelines, movement, okay, so of your crude oil, okay, to the refinery. So that's the midstream. Then you have the downstream, that's the refinery, okay, and other things, the petrochemical industry and the likes. So that is how to answer these questions. So I believe with this I can say goodbye to the class, and I wish you all the best in your exam. Okay, so